afternoon, everyone. Thank you for making it through after your lunch. We have a pretty packed agenda this afternoon. We'll try to get through it so we make it in time for the dinner tonight at 5. I think we have a good bunch of speakers this afternoon. I'll just ask each speaker to keep to their allocated time of about 25 to 28 minutes in case you want time for some questions as well. To kick us off, I'll ask who's going to come up first. Let's go with Mark. So Mark will come up first and talk to us a little bit about IP networking in deep space. Thank you. Clickers are here.
Good afternoon. I'm going to talk about IP networking in deep space. And when I talk about deep space, I actually include Moon, even if in the formal definition of deep space, Moon is not there. So first is how do we or will we communicate in deep space? So starting with Moon, we'll have the following assets that will communicate together. Ground stations and antennas on Earth, communication relay orbiters, and celestial body surface assets like habitats or rovers, astronauts. The link layers, we've been using direct to Earth using CCSDS. It's standard organization similar to IETF, for example. CCSDS stands for Consultating Committee for Space Data Systems. And what is new here is that we will be using our standard Earth Internet technology on the surface of Moon and Mars. So 3GPP, Wi-Fi 802.something. And for deep space and orbital, we'll be using CCSDS again. So, why do we need a networking layer here? Why do we need a network? Well, different from the past, we will now have multiple providers and multiple users and customers. The space agencies now are currently going in RFPs to get services. They will buy services. So they will buy communication services, networking services. They will rent a rover. So we'll be in a phase of buying services. Like essentially what we transitioned from the government-funded internet a long time ago to a commercialized internet. Therefore, all those people will share common infrastructure. Therefore, you need to build a network, especially if you want to enable end-to-end reachability between any to any using the network. All links will carry Internet Protocol, and obviously only IP runs over 3GPP and Wi-Fi, roughly. So that's kind of the picture we will have, where everything will be IP all around. Something to mention is the spacecraft itself, while cruising in the space, actually has an onboard IP network. And also, like on the terrestrial internet, we may have switches, right? So layer 2 switches. In space, we will have orbiters or satellites that will be layer 2 switches, not layer 3. So they will be unaware of IP. They will just switch frames. Mars will be similar. Different in terms of deployment pace, cost, purpose, challenges, but roughly the same kind of architecture. Direct to Earth, satellites, and surface assets. So what's the problem on the network engineering side of it? The main problem, or the first problem, is delay. Earth to Moon, 2 seconds, one-way delay. Earth to Mars, 4 to 22 minutes one-way delay, depending on the positions of the two planets. And Earth to, for example, Voyager, about 24 hours one-way delay. So not the typical internet delays we have. Consequence, an unconfigured stack will just time out, retry, time out, so won't work. I'm sure you have seen this kind of situations in, for example, when you are on the airplane and the delay is getting very long, you get that kind of environment and behavior. So how do we fix this? Easy. We just configure time-related variables. So timeouts, expectations on response. For example, if you do curl with -m, you put a delay on it, works fine. It would be based on expected delays that you know in advance, because all space communications, we know everything about when they will happen, how much time the delay is because of light speed. So where you will be changing those variables in applications, application protocols, transport. IP and UDP have no notion of time, so you don't have to configure anything about those. The caveat is that you have to forget immediate reactions or interactivity. Asynchronous is really the paradigm here. Any fast reactivity to events won't work. Remote management cannot be interactive or fast. Are we done? Not quite. Why? Because we have even more difficult problem. Intermittence or disruptions. So what happens is, until you have full coverage around the celestial body that is achieved by a constellation of connected satellites, like we're essentially building right now around Earth, there will be disruptions, right? The satellite will go out of view, and then as it passes on the other side of the celestial body and come back. So, for example, if you take Moon, the normal delay will be 2 seconds, and then when the orbiter goes on the other side, you'll get a delay of maybe 1 hour, right? So in terms of RTT, you have a few seconds, and then you have a 1 hour, and then goes down, and then, so you see those kinds of patterns. Internet transport sees variability in round trip and knows how to deal with it. However, the expectations on value as variability is different, right? Essentially, internet transport identify this as congestion, therefore it has its own way of recovering. The problem here is the variability in delay is not, most often, not related to congestion. We will see packet drops because by default, a packet received by an orbiter that has no route to the destination will be dropped, right, as a standard IP network forwarding behavior. So, are we done with the problems? Not yet. Oops, sorry. Going on the wrong way. So, one way to fix the last problem is to just make full constellations, right? For Mars, it will require many orbiters. Each costs a lot of money. Each journey takes some time. You have a window to send stuff every 2 years. Moon coverage shall be accomplished earlier, but still then, we'll have other issues that create intermittence. An example that we have seen with, as GPL has seen with the Mars rovers, is sometimes the Mars rovers have not collected enough solar energy so that they have to shut down the radio and wait until the next pass to communicate back because not enough energy, right? So there are all kinds of issues. Nothing else? Well, yes. So we have way many other issues in space. Some, like bandwidth is very limited, is asymmetric. Links are unidirectional. We have radiation, solar storms. Energy is very limited and maybe sporadic. and all the other things that may happen in space. And in fact, that resembles to the IoT use case, right? The IoT is really like, low bandwidth, low energy, intermittence, communication, those things. And obviously, reliability and recovery of any kind, for any kind of event is key, right? In space, when you spend a few $100 million, send a spacecraft in space, and you're looking for getting data from it, that data is very valuable, right? So you want to make sure that the data is not corrupted and sent reliability to Earth for further analysis. So what's the solution to this problem? What needs to be done on the IP suite for deep space? Well, the good part is that IP and UDP and HTTP have no notion of time, so you have nothing to adapt. And that's kind of the most important slide of this presentation. For forwarding devices that are facing intermittent lengths, so the ones that are seeing, that, for example, the ground antenna that is seeing the sky, the edge router on the moon, the satellites, those have to buffer the packets temporarily instead of dropping them, right? When no route to destination is available. So what that means is I send a packet to moon through an orbiter. The orbiter doesn't see the asset, the final destination, so it has to store the packet until it reaches the destination, the asset that may be on the other side of the moon, right? The others, the routers that are on moon, on Earth, anybody else, you don't need to do anything. The other thing you need to do is to configure transport based on a deep space profile. As we've seen, 2 seconds, 5 seconds, 2 hours, 45 minutes. Those are kind of RTT that are not standard for our transport protocols or implementations. So what you need to do is to configure QUIC, for example. I'm talking about QUIC because TCP is, well, more difficult to adapt, I would say. So the right set of values and timers. You have to remember that intermittence is not seen by your transport. It's just long and variable delays. And you should not rely on typical RTT for internal calculations. The other thing you need to do is to make sure your applications has an asynchronous design. This is not the place where you would do a browser and open a page over 45 minutes delay, RTT. You could, but roughly it doesn't make any sense. And you have to orchestrate the whole network. Obviously, as they do today in space agencies, you will need to kind of plan when and what you will be sending to either from the asset or from Earth, because you know in advance that this orbiter you will be able to talk to this orbiter for 20 minutes. Therefore, there's no point of trying to send while the orbiter is out of view because it's not there, right? So there's an orchestration to be done on the whole network. So TCP is not really suitable for space, and obviously everything over TCP. Instead, we're using Profile QUIC. And this is kind of our stack in deep space, which is everything over TCP doesn't work, and everything over UDP, including QUIC for reliable transport, is the way to go over any kind of links. And then you probably have in your head, I'm not sure, looks too easy. Sure. Well, let's try it out. Does IP work in deep space? Well, let's put it to test, and instead of doing Moon, which is too easy, 2 seconds, let's do Mars. So here's a summary of a few simulation results that we have been doing for a couple of years now. And at the end of the slide deck, you'll see more information and also a site where you can get our tools and our results. So, first simulation, just an example. We have done probably a few hundred simulations, but this is kind of a few of them. Earth to Mars, 4-minute delay, one-way delay. HTTP request and response over configured quick, 2 different quick implementations. This is kind of the flow. 1 RTT for connection establishment, 1 RTT for request response, 16 minutes total. It worked. Now we do intermittence, so same as above, but we send a request every 15 minutes. There's a no link every hour for 1 hour, so 1 hour on, 1 hour off. We use our Rust implementation of IP packet storage and buffering. By the way, this is like 500 lines of code. It's obviously not for commercial purposes or production purposes. It's just used a ton interface on Linux, but it just shows that it's not that complicated. And well, packets were stored. There are the results in a sawtooth pattern, as I was describing, and there were no packets lost. And if you look at here, the difference here, you will see that when there is no the destination, the Mars asset is not available, you store packets, and then on the way back too. So, can we do longer delays? Can we do packet loss? Same as before, but Earth to Voyager. At that time, 2 years ago, we did one with 18 hours, one-way delay. 2 RTTs to receive the response as before, but now it's 72 hours. You start the simulation, a wall clock time, and you wait roughly the end of the week before getting the answer. Another one, 24-hour one-way delay, 5% random packet loss. We sent 10 HTTP requests in sequence. We use the NetM, TC-NetM tool for randomness. 2 servers to decide which packet will be dropped. NetM decided to drop 2 server packets, so the responses. The lost packet were resent in an XRTT as additional frames into the current packet, because you may know that Quick is actually like a pipe. It has streams in it, and then many frames can be contained within a single packet. So what happens is the next time the sender has received the axe and know now that there are packets missing, so it will resend the data into new frames, into new packets, and then send it back. So the total time was the same because the resend was done during the 10 request and response. So that's just a small summary of simulations we've done. What about network management, QoS streaming? All those tools are essentially can be used as is if you make sure that what I just described before, forwarding devices, seeing intermittence should store the packets, transport should be configured, and application should be asynchronous. And don't use TCP. So network management is a good example where SNMP, while it's being deprecated by the ITF and in general, it uses UDP, which has no notion of time. So we were able to do SNMP get and put easily the first time without any change in the net SNMP package, just because we just add the timeout telling the client to wait the RTT, which is longer, and then it works, right? If you want to use a netconf over quick, there's a draft coming out for netconf over directly over quick, or you can use restconf which is netconf over HTTP, which may be used quick. QoS, same as we do right now. Naming, you have to use DNS locally on the celestial body network. You don't want to have resolution requests from the moon to Earth and back to the moon, or from Mars to Earth and back to Mars. You have to make sure that all the names you need are actually pre-cached on the celestial body. Emergency messaging, time distribution, NTP. Surprisingly, NTP works good in space. You can do time distribution. The only caveat is you have to make sure that the return path has the same delay than the forward path. So that means that you have to be careful on how you deploy it. Media streaming, you have many other choices, RTP, whatever. So the key point here is by a few adaptations, you can reuse all the IP stack protocols, applications, tools without any big issue. Now, the difficult problems. First is congestion, because as I described before, when you buffer packet in space, that means you will have very valuable RTT, which will be interpreted as congestion if it's not actually congested. So there are short-term solutions for this, but my guess, and we're already seeing some researchers thinking about modifying the current congestion control protocols, such as BBR, to be more better in this environment. Routing at scale. The problem here is, given that you don't have a fast reaction to events, that whenever the topologies change, the advertisement will arrive somewhat too late. So you will need some kind of autonomous things in terms of routing. Another difficult problem is the key life cycle. Long-lived connections may need different kind of key renewals. And for example, certificate validation cannot be done by going back to Earth, right? So you need to make sure that your old trust chain is actually local to the surface of the celestial body. So if you have to verify a key, a certificate on Moon, then you have to make sure that all the trust chain is local to the Moon. Same for Mars. You cannot go down to Earth and back, because while going to Earth, you may be with intermittence with the satellite not being at the right time when you need it, so therefore it has to be local. So these are examples of problems that are probably more later, given that the speed of installing new satellites and assets on the Moon is not one every day, at least for now. So we have some time to fix those, to work on those bigger problems, but still. As conclusion, the Internet Protocol Suite is being deployed in deep space by temporarily buffering IP packets and forwarders facing intermittence, configuring quick transport with a space profile, or use plain UDP, and for applications, modifying timeouts appropriately and apply an asynchronous design. There's more work to be done. There's an ITF working group now called TIPTOP, which stands for Taking IP to Other Planets. You're really invited to join and contribute. And for more information about the initiative of Deep Space IP that was started before the TIPTOP working group, we have on this GitHub repo a few tools that we've been using for a couple of years. This repo will continue to be updated with additional tools that we have been using. And there's the information about the working group TIPTOP. And there's also a Discord channel about this. So if you want to join, please contact me. And that's it for me. Thank you for your attention.
Thank you, Mark. Any questions for Mark? Yes, please. Just come to the mic at the front. Give us name, affiliation, and question, please. Thank you.
Natalie Trenneman, Amsterdam Internet Exchange. Thank you for your presentation. I was fascinated. A lot of it actually makes sense when you think about it. But then I saw in your slide NTP. And NTP can have some really fishy behavior sometimes, in the best of times. And then I thought in space, and you just mentioned, yeah, it just works. If you have time, I'm looking at Mark, maybe 30 seconds, a little bit more on that, because that's fascinating.
Yeah, good question. So we started simulating NTP, and with the long delays in our simulator, and it worked pretty well. So it was kind of a surprise. I was expecting more problems. Then I went to the NTP implementers and experts in the ITF, and they told me essentially what I just said, which is NTP will synchronize whatever the delay if the delay is the same on the way up and down, so on both directions. Then, but the problem then is if you have an orbiter, you have to make sure that if you're trying to synchronize from Earth the asset on Moon, then you have to make sure that the path is currently available and will be available during the, and then you have to kind of stop NTP until the next pass. So there's a, therefore you have a deployment problem more than a protocol problem, quote, quote. Having said that, we haven't fully done, there's a current draft being co-authored by me and a few guys from the NTP working group, and we're trying to sketch out how this will work. So I cannot make any promise, but it looks doable. And on the deployment side of you can think of having an NTP server on the satellite, and so therefore you just synchronize the satellite from Earth, and then satellite itself is just a stratum 2, and then will be the reference for. The other thing is for the purpose of space navigation, they have clocks everywhere, so we may also use those, even if traditionally we're not used as NTP servers. You add an NTP server to them. So there's different ways, and the elephant in the room is the time zones, and and that's another kind of worm. The astronomers are working on this for the time reference essentially in the asset. So that's, I leave it to them, because NTP currently is based on UTC, right? So what's UTC on Mars? Given the time, the propagation of time is different depending on the position of planets, right? The way the space agencies are using is they have the notion of a local spacecraft time. So, for example, each satellite around Mars has its own time, and then they calculate everything so that when the processor is executing something based on time, it's sent with its own reference, so it doesn't have to calculate, oh, UTC, I received it 20 minutes ago, therefore, So there's multiple problems with the reference of time in space. I'm not touching it. I'm just trying to make NTP work.
Thank you so much. Speaking of time, we've just run out of it. Thank you so much, Mark. If there's anyone else that has any questions for Mark, please, after the break, because we're just a little bit behind time. So next up will be a combo of Paresh and Warren talking to us about new stuff at the IETF. Oh, you get yours up there. Do you want to speak together or in series?
I'll talk first, then Paresh.
All right.
So with that said, hi
Because
all. I'm Warren Kamari. We also have Paresh, who's tying his shoes. And we are going to tell you a little bit about what's new at the IETF and the ClickerWorks. So that we have a lot of material to get through. So a lot of this is just going to be a summary, and the slides have links in them. So if you'd like more information, at the end of this, please download the presentation, click on the slides, click on the links, they'll have more info. So for the few people in the room who don't know what the IETF is, this is basically our mission. It's to make the internet work better by producing high-quality, relevant technical documents that influence the way people design, use, and manage the internet. Unlike some other SDOs, the IETF has a strong sort of ethos and culture, and that's basically summed up in these 4 points. Basically, everyone may participate. Unlike some other SDOs, you don't have to be a member of the IETF. We don't really even have the concept of membership in the IETF. If you participate, you're an IETF participant, you're now one of us. Also, different to many other SDOs, all of the work that we do is made available for free. So if you've ever read an RFC or used any sort of IETF work, there is no need to sort of have a paywall or sign any sort of licensing. All of our work's available. Please come and use it. The way that we judge whether or not a contribution should move forward, basically if a document should be progressed, is if the people in the working group seem to think that the document is largely ready. And that's based on if the technical issues have all been addressed. This is different to other SDOs in that we don't have the concept of voting. There's no people agree and everybody votes. It's does the document generally seem cooked, and then other than just the working group, does the full IETF seem to think that the document is ready? And then the last one of these is the way we determine if something is successful is through voluntary deployment. So if we write an RFC and it gets widely deployed, that's a success. If we write a really great RFC and nobody deploys it, that's a failure. So I've been talking about the IETF as though it's a single thing. It's actually made up of a bunch of different groups or sort of organizations. Here are the 3 primary ones. The majority of the work happens in this box on the left. That's the IETF itself. Over on the right, we also have the IRTF, the Internet Research Task Force, and that does much longer term sort of research type things, 5, 10, 15 years out type work. It's also where a lot of the academic people in the IETF come and participate. And then in the center of this box is the Internet Architecture Board. It's one of the leadership groups in the IETF, and it does long-range technical direction. It also does liaison coordination and things like outreach. Hi all, that's why we're here. But generally, people just refer to all of these under the sort of umbrella of IETF. So the way that work actually gets done in the IETF is in working groups. There are between 120 and 150 working groups at any point, and these are grouped together into various areas. There are 7 areas at the moment. We've only listed 6 here. But for example, BGP is done in the interdomain routing working group, and that is logically in the routing area. Things like DHCP, NTP, those are done in the internet area, and this is just a grouping to try and sort of organize work and make it easier to track. In this diagram, we also show 2 sort of pillars. Wow. 2 pillars, ops and management and security. Ops and management is generally responsible for making sure that any of the protocols we develop can actually be deployed in real-world internet sort of networks. Over on the right, we have the security area, and it's responsible for making sure that the protocols we develop are secure. It also does its own sort of protocols as well. For example, TLS, IPsec, etc., are developed in the security area. In APRICOT, probably much of the interest is going to be stuff in the ops and management area and bits of routing, internet, etc. So Many SDOs say that they support good remote participation. The IETF actually takes this very seriously. We have 3 meetings a year, 3 in-person meetings, generally 1 in North America, 1 in Europe, 1 in Asia. But we also have really good remote participation. So at any given plenary, sort of in-person meeting, between 35 and 45% of people are participating remotely, and they participate as first-class citizens. The way we have participation set up is you participate generally through this tool called Meet Echo, which is built on WebRTC, of course, an IETF spec. But you participate as somebody in person would. With that said, there are definitely some advantages to be able to show up in person. For example, there's the hallway track where you bump into people, you can meet with them, chat about work, etc., dinners, etc. But if you can't make it to an IETF meeting, please still come along and participate remotely. It really works very well. In addition to things like the 35 to 45%, there are also working groups that hold interim meetings, which are virtual only. So between the sort of 3 primary meetings, about 40% of working groups have remote-only sessions, so you can just join them, dial in, etc. As I mentioned earlier, all of our work's available for free. Most of it happens on the site that we have called datatracker.ietf.org. That's where all of the in-process work is happening. So if you'd like to read an internet draft, things that people are currently working on, it's over there, as are all of the meeting recordings. So all of our sessions are recorded, posted online. So if you'd like to see what a meeting actually looks like, or just how decisions were come to, it's available there, as are all of the mailing list archives. Officially, work happens on the mailing lists, and there's a lot of email that happens. If you're interested, you can follow the archives, or please just join a mailing list. It really is quite fun. So there is some new work happening, or here's a list of new working groups. We're not going to go into detail on what any of them are. You can figure it out from the names, generally what they're working on. But again, as I mentioned, these slides will be available after the session. Please just download it, click on some of these, and you'll see what the working group is working on, what its charter is, what documents it has, etc. So, birds of a feather flock together. New work starting up in the IETF generally happens through a bunch of people getting together and deciding that they're interested in a topic. The topic seems kind of related to IETF stuff, and then people discuss if there's sufficient scope and interest to actually form a working group. At the upcoming IETF 125 in Shenzhen in March, there are 2 BOF sessions, Catalyst and Onsen. Catalyst is an effort to try and, yeah, some of the names are kind of contrived. I can see Jen laughing at them. Catalyst is an effort to try and sort of corral all of the AI discussions in the IETF into a single place. Yep. And at least make sure that working groups aren't sort of working against each other. We're generally trying to work in the same general direction. Onsen is probably of more interest to many people here. This is a working group which came out of the IAB workshop, Next Area of Network Management Operations. And one of the outcomes from that workshop was a discussion that operators would like to be able to configure something like a service abstraction. So an example is like a virtual circuit tunnel from one side of a network to another, instead of going to each router along the path and being like, you're a Cisco, I need this Yang model, you're a Juniper, I need that one, and stitching it together. So basically up-leveling abstractions and providing a single type of abstraction to configure various services. Speaking of workshops, the IAB held 2 recently. The first one was on IP address geolocation. This was a purely online/virtual workshop. It wrapped up recently, and we hope to publish a report soon. But if you'd like to see what a workshop is actually like or what was discussed, the recordings are all linked there. Please download the slides and follow them. But what this workshop is IP geolocation was originally created to try and get users to a data center relatively close to them. right? You would like users to be able to reach a data center nearby because the latency and performance should be better. Over time, it has morphed into something to actually get finer control of where users are. So it's certain things like, I would like to get the user to a close pizza shop. It's a very different type of problem. Or I would like to make sure that this content can only be shown in these particular countries. It's a very different type of use case. So basically, is IP geolocation still a reasonable solution for these type of use cases? If not, what might be better? But also, if something else is created, how can we do these sorts of things in a privacy-preserving manner? The other one was a joint workshop with the W3C on age-based restrictions. As you've probably seen, there is a lot of regulation coming around these days on making sure that people have to be a certain age or older to view certain types of content. And instead of having sort of 100 different specifications and regulations people have to deal with, if something like this happens, is there a way that we can do it in a less onerous manner? But much more importantly, if something like this happens, is there a way to accomplish these types of things in a privacy-preserving manner? So instead of having to upload your driver's license or passport, is there some other privacy-preserving way of proving your age or other type things? AI clearly is the new hotness. Everything's about AI these days. This is no different in the IETF. There is a lot of discussion across many different working groups and many different areas. These are just a small sampling of them. The first one, AI preferences, is looking at a way to extend the, basically an easy way to think of this is something like robots.txt, but instead of only being able to signal, can this content be crawled? Also, if you crawl this content, can you use it for AI training? Or if you follow a specific set of URLs, get to some content, can you use it for AI at all? What is the site owner's preference? Somewhat related to that is WebBotAuth. There's been a proliferation of web crawlers recently, and a lot of site owners would like a way to be able to make sure that a crawler is actually who it says it is. Generally, at the moment, this is done through user agent strings, and these are easily spoofed. So if a crawler says that it's like Microsoft crawler or Yahoo crawler or whatever, a cryptographic proof of that. Somewhat related to this is AI data centers are somewhat different to sort of older, I'm going to say, legacy-style data centers. Often they're a lot denser, much higher power usage. And so IETF is working on this through things like Rift and Green. Green is an effort to expose a lot more energy metrics out of devices. So instead of just saying this router draws 5 kilowatt, being able to say this much of the power is used for fans, this much is used for actually forwarding, this is the routing engine. That way people can optimize energy use, how much is used for cooling, etc. Also, often AI data centers use very dense flow trees. Are there better ways to do routing in that type of environment? So like routing in factories as Rift, etc. I'm going to talk about DNS a bit, because DNS happens to be my favorite protocol. There is a huge amount of DNS work happening in the IETF. One of the bits I'll call out is the DELEG work. At the moment, parents can only provide very limited information about their sort of DNS children. At the moment, it's mainly sort of, here are the name servers for the child, and these are the IP addresses, potentially. DELEG is trying to extend this so that instead of just providing that, you can also say, this domain is an alias for this domain. Or, I'm the authoritative server, or I'm the parent name server, child is over here, it speaks DNS over TLS, here is the certificate, these are the ports you should use to contact it, etc. So basically redoing the DNS delegation model. And with that, I believe I'm handing it over. Paresh.
Thank you. All right, so carrying on, some of the highlights about some of the other work that's going on at the IETF. So around operations, as you saw, operations and management is really important to the IETF. There's the whole ops area that looks after operations. There's a number of working groups that sit under ops. And I'll just talk about a couple of them. Warren's already talked about green, which is the, once again, a contrived name there, getting ready for energy efficient networking, tasked with standardizing some of the work around, measuring power information, terminology, and so on. There aren't any real standards about this at the moment, with the ultimate objective being able to optimize how energy is used across a network. The other area that I wanted to sort of briefly touch on is the NMOP working group, so network management operations. That working group is really tasked with providing an avenue for operators to share experiences around operationalizing network management technologies, any issues they have, any challenges, and finding solutions for them, best practices, and so on. So very interestingly, and Warren alluded to this as well, a lot of the work that we've been doing on network management over the last 20 years came about as a result of this very seminal network management workshop that happened in 2002. And out of that came things like RESTconf, NetConf, Yang data models, and so on. And so at the end of 2024, so 22 years later, there was a follow-up to it, which is the NEMOPS workshop, so Next Era for Network Management Operations workshop, where, once again, it was a similar kind of thing. It brought together operators and the protocol developers to understand what was working, what wasn't working, what are some of the more new requirements that are emerging that we could work on, right? So one of the outcomes of that was really the work that is going to be tackled by the ONSAN working group. The other thing that was seen as something that was common to a lot of operators was how they actually consume the network streaming, the telemetry data that's coming from Yang push, right? So Yang push into Kafka, into some sort of time series database for analytics and so on. So that can be done clearly, but it's not easy to do that. So one of the work items that has been taken on is to really simplify that, build better integration between Yang push and Apache. Finally, the IEPG, right, the Internet Engineering and Planning Group. So this is, well, it's not technically part of IETF, but it's an informal gathering. Happens on the Sunday prior to the primary IETF meetings, right? In-person IETF meetings. It provides an opportunity for researchers, for operators, and so on to share some experiences on operationalizing internet technology. Okay, so moving on, IPv6, two primary groups that I've got here. There's V6 Ops. That group, that working group is really tasked with the deployment aspects of IPv6, right? Understanding what works, what doesn't work, some of the best practices around that. And then there is 6Man, which is really tasked with the maintenance of the IPv6 specifications, right? So any protocol changes that need to happen on IPv6 happen there. So there's been a bunch of recent work that has come out of V6 Ops. So RFC 9898 quite neatly packages a lot of the issues that we've seen with neighbor discovery over the years, right? So there's about 20 odd issues that it looks at. They've all been covered separately in the past, but this RFC brings them together and basically, derives some common causes for these issues. There's also a bit of work that's been done on using DHCP-v6 prefix allocation to actually allocate unique IPv6 addresses to hosts on a broadcast network, right, as opposed to individual addresses. So that was possible to do with Slack, but this extends it to use DHCP-v6 PD. And 9762 in 6Man is also using that, or at least building on that by using RAs to indicate that DHCP-v6 PD is available to the clients and is actually preferred. So if you have an opportunity to use that. Okay, so routing. I'm pretty much going to talk about BGP, right? So a few groups that are associated with BGP and do BGP work. The primary one of them, IDR, or inter-domain routing. Always a lot of work happening in that space. Of late, there have been work items around flow spec enhancements, around segment routing, and so on. And there's also this other, well, slightly I guess, overdue bit of work, which is to update the base BGP4 specification, right? So today, RFC 4271 describes the base BGP specification. This RFC actually came out in January of 2006. So it's a little bit long in the tooth, right? And the thing about this RFC, which may come as a surprise to some of you, maybe even a shock, is that it's actually not a full internet standard. So BGP, as defined by 4271, is actually still a draft standard. So within the IDR group, there's been a long-standing work item, 16 years or so, to upgrade the specification to an internet standard, a full internet standard, right? So that work's finally kicked off. So there is a 0.0 version of RFC 4271 biz that's out. I think it came out October, which is attempting to do just that, right? Bring it up to speed so that we can now reclassify or classify it as an internet standard. Now, a couple of other groups to do with BGP around operations. There's GROW. So GROW is concerned mainly with the global internet routing system, right? So it deals with things such as visibility. So some of the work on BMP comes out of that. The stability of the internet routing system, the security of the internet routing system. And there's CyberOps, which deals with all things RPKI. There's a session on Wednesday that they'll go into further depth on what CyberOps is doing. So if you're interested, I urge you to attend that. One of the significant works coming out of it is going to be a version 2 of the RPKI to router protocol. Okay. On security and encryption. Okay, there's been a lot of, I guess, development in quantum compute capabilities over the last few years, right? And there's a bit of a fear out there that a cryptographically relevant quantum computer is not that far away. Now, if it does actually emerge, then there's a risk that today's cryptographic algorithms that are based on things such as RSA, Diffie-Hellman, elliptic curve cryptography, and so on, could be broken. And that's not a good thing for any of us, right? So the NIST in the US has been working on this since 2016. So they've actually went out and asked for candidate solutions to come up with these quantum-safe algorithms, right, to replace RSA, Diffie-Hellman, and so on. So in August of 2024, they came out with the first bunch of them. The algorithms are around key encapsulation mechanisms and digital signatures, right? So so now we've got them. We've got to incorporate them into IETF protocols like TLS and IPsec and so on. So multiple working groups are actually working on that. Now, if you're interested in post-quantum cryptography, as we call it, there's a very, very good document, right? That's written there that you see, the post-quantum cryptography for engineers. I've read this about 3 or 4 times. It's such a great document. You do not need to be an expert in mathematics or physics or quantum mechanics or anything. But still, by reading this document, you'll become very knowledgeable about what is going on and how we're solving this problem. There's open authorization as well, a new BCP that came out in RFC 9700. Okay. On transport and tunneling updates, quick, very interesting as always. Probably the key thing here that I should call out is that the quick. The quick working group has been recharted to work on quick over essentially TCP, right? The other bit of work is the multipath extensions draft that has been worked on for a very long time is ready to be published. MASK, which looks at tunneling many different types of protocols over HTTP3, right? Continue to churn out some good solutions. So today we have solutions for proxying UDP, IP, Ethernet over HTTP3. And finally, there's a media over quick working group. Now, what they were tasked with is really to come up with a relatively simple, low latency solution for both the ingest and distribution of media traffic, right? To facilitate applications such as video conferencing, gaming, and live streaming and so on, right? So they are working on this MOQ transport protocol. Okay. Space, I don't think I need to say anything about space. That's all been covered by Mark in the previous presentation. But just to point you to the work on the IETF and where that's happening. So there's the tip-top working group that Mark alluded to. It's scoped with communications up to the moon, Mars, using DNS quick. There've been working groups, and there still are working groups in the IETF that have dealt with some of the problems that Mark highlighted, right? So you've got the time variant routing working group. You've also got the delay disruption tolerant networking working group, DTN, as well, that's been looking at this problem for some time now. And related to this as well is a research group, the Space RG, that is looking at things that are a bit closer to Earth, right? So LEO, GEO, and cislunar kind of environments, and how we work in those environments. Okay, so I've got a couple of minutes left, so I'll try and wrap this up quickly. The Internet Research Task Force, as Warren mentioned, it's like a parallel body to the IETF, whereas IETF it develops protocols, whereas the IRTF does long-term research, and some of this then makes its way into the IETF as well. So a number of different types of groups exist here. Some are technical, some are more sort of policy-focused. Some of the interesting ones that at least I've been attending recently are the QIRG, which is doing research on the quantum internet, quite interesting about how it can connect up these distributed quantum compute sites, do things like quantum key distribution and so on. There's also policy-focused ones like a research group that is looking at human rights protocol considerations, right? How can we use technology to improve human rights, to improve or overcome the digital divide, right? Get internet out to more people. So a lot of interesting stuff happening within those RGs as well. So that kind of brings us to the end of this presentation. There's so much happening here that it's very hard to cover this in 25, 30 minutes. A lot of very interesting work that has been done in the IETF. What we would like to hear from you is, what more would you like to hear from us about, right? On what is happening in the IETF, how can you participate? The IETF is always seeking more operator involvement in it as well. So that's really important to see. So we can really hear from the actual users of the protocols as to what the requirements are. And finally, once again, as Warren mentioned, the next IETF is in our region. It's in Shenzhen from 14th to 20th of March. If you cannot make it in person, you can get fee waivers for remote participation, right? So that might be a good way to get into it. It doesn't cost you anything. The time zone is friendly. Attend a few of the meetings, see how it actually works, and that may, trigger a deeper involvement in it going forward. So, on behalf of Warren and myself, thank you very much.
Yep. Yeah, and we'd really like a lot more operator input so we can make sure the protocols we're developing actually work in real networks and work for you. So please participate in 125, either in person or remote. I don't think we have time for questions.
20 seconds.
20 seconds. And of course,
now or never.
And of course, feel free to hunt us down after this, or there are a bunch of other IETF participants who will be happy to help answer questions.
I think just a quick yes or no question for me. Are you seeing more and more operator participation in the last year, let's say?
In the last year, I don't know over that timescale. Maybe. I mean, it sort of goes through waves. It also depends on how you define operators, right? The scale seems to be changing. At one point, it was much lower, sort of IP layer. There's a lot more web stuff. So I'm not sure I can really answer that, but hopefully.
Understood. Okay. Thank you so much, guys. Appreciate it. Up next, we should have Jeff Houston talking to us about BGP in 25.
I'm sure the world has been completely bemused by AI, and the fog of AI-phoria seems to be everywhere. You can't spend $1 trillion on a bonfire of optimistic vanity without making some kind of massive bombshell in a crater, which is what's happening. And almost everything else in this industry is kind of sitting there trying to figure out what to do while all our collective attention is spent on the next fuzzy piece of AI slop. Hopefully, it will go away again. Somehow I doubt it, but $1 trillion is being spent over there. Underneath it, though, is still an internet. Underneath all this euphoria of, oh, we can do this stuff, possibly, is actually an internet that's still working quite hard. And oddly enough, one of the few ways of looking at all of the internet all at once is actually looking at it through the lens of the routing system. Because the routing system is one of the few tools that brings all of your networks to each BGP speaker. You see everyone from your own router. And oddly enough, that can give you an amazing insight into the dynamics of the internet. This is a busy graph. It starts in 1994, 30 years ago, right? It charts the size of the IPv4 routing table using peers from both route views and RIS, and as they appear, it's sort of each line of dot in each colour through that entire period 3 times a day. So it's a huge amount of data. And you can see inside there this sort of euphoria of the internet from its slow beginnings in the early 90s through to the first great internet boom of 2000, child's play, and then the increasing adoption through firstly residential DSL and then residential fibre that actually brings up, and then with mobiles, a network of billions. And through the noughties and 2010s, that evolution just kind of continued. Interestingly, around 2011, we started to run out of addresses. You wouldn't notice it from this graph. You really wouldn't. Almost the only thing that seems to have stopped this euphoric growth was COVID. And that kind of slowdown of investment across the COVID years is actually really obvious. But if you look hard, you find in the last 6 months, the growth has started again. Let's blow that up a bit and have a look. This is IPv4 in 2025, and there really is 2 halves to this. The first half of the year was kind of more modest, and then the end of the year was sort of a slightly higher growth rate. We're now up over 1 million entries in the routing table. There's some variation. We all see a slightly different internet. There's about 45,000 routes that differ. That's the way routing works. We each have our custom view. A couple of blips were obvious because we don't use BGP for traffic engineering the way we used to. And what that means is that the massive amount of more specifics in the routing table is coming out. Interestingly, the US Department of Agriculture dropped 3,000 more specifics. Why they had them, I don't know. What they do, agriculture, I have no idea. The middle of the year was slightly more interesting. This sort of blip. On July the 7th, the point in Egypt where all the wires converge, the Ramesses Central Building, it's really old. According to my colleague Joao, who's actually tried to install a route server there, it's not the glitziest of buildings. It really isn't. It does keep the rain out when it occasionally rains, I've been told, but that's about all it does. However, it did catch fire. Oops. And all of Egypt went down. Oops. And it took them a week to actually build it all around it again and bring it back up. So that was the glitch. A whole lot of details about things changing. Who's growing? China Mobile. That's number 1, number 3, and a few others down there. Amazon grew in terms of routing entries. Who's pulling routes out. AT&T, whoa, dropped 2,000 routes. We talked about the Department of Agriculture, Cogent. In fact, a bunch of these large provider networks are actually in V4 terms getting smaller in terms of the number of prefixes they're routing. Interesting. So let's look at a different view, addresses. How much space are you advertising? Different picture, isn't it? Because it's now compressed into a little bit over 3.2 billion addresses in V4. The rest are basically reserved, future use, whatever that means these days, and so on. You can see that by the time we really started to build out the network in the sort of post-NFSnet era, we'd already handed out 1 billion addresses already. And the entire RIR history managed a little over 1.5 billion addresses and managed to take a couple of decades to do it. So across that middle period, that entire growth that we saw in prefixes actually also had some degree of address growth, but not as intense. Here, address exhaustion is clearly obvious. By the time IANA ran out in 2011, and then the RIR started introducing, oh my God, this is serious moments, then the address outflows were really constrained. And the only things that happened near the later part of this graph is the US Department of Defense, which had been sitting on a fair deal of address space, decided they'd announce it, whatever that means. So a bunch of addresses appeared in the routing table. Why all the colours down below? Because everyone sees a different network and a lot of folk use default and don't have a whole bunch of other routes in there. And it makes the graph look pretty cool. 2025, that's not growing. It's kind of getting smaller. And indeed, that's what happened to V4. In terms of address span, it shrank. One of the more interesting ones, Amazon was sort of having a period of uncertainty. On the 4th of November, they withdrew 15.8 million addresses. On the 10th of December, they announced them again. Gee, thanks. A whole bunch of changes through there. Look at it later. I'm not going to go through it. Amazon is interesting. Amazon is really interesting. Because while everyone else is going, surely we're in a post-V4 world, Amazon is going, no. I'm just going to announce another 108 million addresses right at the end of 2024, which is a huge amount. And they're currently announcing, or at least as of January this year, 158 million addresses into the routing system. They're big in V4. Go ask them what they're doing with it. The larger system, in terms of addresses, we shrank by 10 million addresses over the year. That's the red line. The green line, the advertised thing, again, we saw it shrink by 10 million. The blue line is the registries. What happened in March? Go ask LACNIC. I haven't a clue, but they were mucking around with their registry and all of a sudden addresses disappeared and then magically in April they reappeared. Phew. In addressing terms, there's a bunch of winners and losers. People who get rid of addresses, people who buy them. Some of this is bookkeeping. Google moved a whole bunch of addresses from Google's 15915 or whatever into Google Cloud. DNIC in the US was doing some housekeeping. BT bought EENet some time ago and finally moved the addresses over. But some aren't. AT&T got rid of 3.4 million addresses. That's a lot. Just got rid of it. Alibaba, they rearranged a bit, but they also seem to be getting rid of some too. Telenor, there are a few of the old traditional ISPs, I think, are monetising what they've got to the extent they can, while addresses are still worth something. Because it's not on a slide, but the price of addresses in 2025 across that year dropped. The height at the end of COVID was $60 an address on the market. Today's price is between 15 and 20. So if you're holding 1 million addresses, you've just made an awful lot of loss on paper of those assets. And if you're thinking, I'm waiting for the price to get high, I think you've waited too long. It's all over. So V4, still growing, bizarrely. Address use declining, particularly in the US, as they're sort of monetizing what they've got. They don't need as much. Cloud infrastructure, Amazon, whatever drugs they're on are great. They still believe. And the use of more specifics, BGP for traffic engineering, is falling. Why? Because data centers are picking things up. Traffic is closer. I don't need to do traffic engineering. So V4 is kind of in its sunset days, in theory. We're over it. It's all in V6. And if you look at the big 30-year view, you'd kind of go, yeah, that's more like it. Great exponential chart. Looks brilliant, sort of. In 2025, it's growing, but it's not exponential. It's linear at best, and it's kind of patchy. Who was the big ones here? A telecom company in Hong Kong, WeCast, was the only one that really did a blip. There's not a huge amount of growth in V6, and most of it is in more specifics. And even the more specifics have stopped growing since 2022. 45% of all V6 prefixes are /48s. Slicing and dicing is where we are. There's higher levels of more specifics in 6 than 4. The advertising span is not the same exponential growth pattern. It's far more modest. Because in actual fact, I think the money behind V6 deployment was never there. It was never kind of an explosive investment in V6. It was far slower, far more considered, and there are folk who are still sitting there waiting, and that's fine. So what you see there is actually a different kind of growth chart. It grew, but look at those last few years. The address span in V6 since around 2022 has not. That the network itself, in terms of the addresses it covers, isn't growing anymore. The advertised address span in 2025 shows this. It was actually falling through most of the year until Cable One in the US saved the day and announced 4,000, what am I dealing with? I think they're I need better glasses, /32s. Thank you, Cable One. But that was the only real change. That this network is not changing very much and certainly not growing in terms of its advertised address span. These are little things. So yeah, it grew by 20,000 entries. It grew by about 4,000 /32s, but that was one provider. There were 2,000 new ASs and 1,000 that stopped. Yeah. So it's sort of expanding, but, in a very measured way. So if I'm buying a router today, how big should it be? Because, of course, the most expensive thing in a router is still the forwarding memory, the thing that you stuff all your routing tables into. And these days, you need at least 1 million entries just for the external BGP v4 fib. So you need 1 million now. What do you need in 5 years' time? Because hopefully your router is still working in 5 years' time. There's a fair deal of uncertainty going on, but I would hazard a pretty sure guess that you only need 1 million. That the growth rates are not really there. And that the V4 growth, although the last few months of 2025 was big, in reality, not convincing. I wouldn't go and buy a whole heap of memory just on that. So higher than we thought in the last few months, but nothing spectacular. V6, same kind of story. It's somewhere between linear and slightly polynomial, but I reckon the growth rate's still largely linear. It's 250,000 entries now. In 5 years, it might get to, 350,000, possibly a bit more, but nothing spectacular. The growth model is uncertain, but not really changing. Why not? We can't figure out where to put more internet. We've stuffed it into big computers. We've stuffed it into computers on your desk. We've stuffed it into computers in your pocket. We've stuffed it into your cars. We've stuffed it into everything we can. What's the great untapped market for V6 devices? And the answer is none of us know. And we're unable to sell it. We're not growing, not because V6 has run out, it hasn't, but because the economic models of a network penetration have largely reached the end of its path. No one's figured out what the use is to have a whole bunch more devices connected to an internet. And for God's sake, don't give me an AI answer. That's not doing a thing for this. And a point of fact, inside those AI data centers, it's all V4. Don't know why, but that's the way they're built. So this network is now at a point which is largely dominated by a saturated end user market. We've gone through the whole mobile explosion and there's nothing else left. So the constraints of the routing system are largely not under any further pressure. We can run this for some decades now, and by the look of it, it's not going to be under much stress, at least in size. Updates could be different. BGP is a noisy protocol. It doesn't really know when it's finished. It keeps on thrashing around. But interestingly, in V4, we build a tight network. That yellow line is the size of the routing table, up and to the right. The blue line is the number of updates. Whoa, kind of flat. The violet line at the bottom is the number of withdrawals. I'm like, this is a network that over the years, as it gets bigger, gets quieter. That is a complete contradiction in terms. The V4 network is remarkably well behaved. It's been steady for quite some years. Even the prefixes that are unstable, 20,000 a day. Whatever job you're doing in your NOCs, in V4, it's brilliant. It's keeping this network to a level that it just hums. It's not a problem. So V4, it's cool. It converges in 50 seconds. 20 years ago, it converged in 50 seconds. A smaller network with exactly the same dynamic performance. This is brilliant. And it's not that BGP is any better, it's the same protocol, and a bigger network should mean it would thrash more. It does not. There are some pathologically bad people. A small number of prefixes generate almost all the updates, and 5% of all those ASs generate 80% of all the updates. We know who you are. The lights are too bright for me to see if any of you are here. One of you, two of you maybe. We know who you are. But oddly enough, most of the network is as boring as it comes, and a few folk have just pathologically misconfigured their routers and causing the updates that we see. V6, completely different story. Oh, it's just larger address space. Yeah, it might be, but oh my God, no one's looking. This is not a managed system. If you look at the update rate, it's sort of commensurate with the number of prefixes that are in the system. That wasn't meant to happen. The trajectory is, as the system grows, the updates grow. That's not meant to happen. And the withdrawals keep on growing. That's not meant to happen. Whatever you're doing with V6, stop it. Just leave it alone and it might get better all on its own. Something's going on there that says that V6 it's getting a little better in the last 12 months, but it's still not very good. Unstable prefixes, more and more and more and more. I really wish you'd stop it, whatever you're doing. It's not good. Interestingly though, convergence time, it's 50 seconds. Why is it 50 seconds? Because the average AS path length is around 3, and the MRI timers in BGP are 30 seconds, roughly. And it takes 1.5 MRIs to converge as long as you run a short, dense network. And by the way, don't tunnel. Tunneling is evil, tunneling is unstable, and tunneling is what was happening for the first few years in V6. That left-hand side of this graph is you guys tunneling, and tunneling is evil. Don't do it. In V4, there are a small number of pathological loonies. In V6, there are 3 pathologically loony ASs. Just 3. We know who you are. 20% of all the updates come from those 3. We thank you and note that you keep on doing it. Just keep on doing it. It's weird. Conclusions. There's no more scaling pressure. There really isn't. This compressed topology keeps on thinking that things work. Instability levels are high in some areas because those are just super update generators. The expansion of the network is largely finished. It's still growing and it still catches out some people, like Optus in Australia about 1.5 years ago, but on the whole, it's pretty easy to stay on top of the fib growth, making sure that your max prefix counts are within reasons. It's not growing that quickly. So the long-haul traffic engineering is no longer a problem in BGP. You just use data centers. They're nearby. Most of the network is now a severely constrained last hop network, and the BGP network is not so important to bring in traffic to customers. It's sort of the small margins. So if you're running a network, don't be Optus. Understand your fib capacity. Don't let the number of routes get above that, because otherwise bad things happen and you get reported in the press and people like me make fun of you. It's not good. So max prefix setting is a big one. Keep an eye on that. When it's exceeded, make sure that you don't just collapse and turn everything off. That's a really bad idea, particularly if your support centre is on the other side of the connection. That's a terrible idea. So yes, look at your partitioning. Right now, both V4 and V6 both need much the same. 1 million V4 entries takes up as much space in memory as 250,000 V6. So your partitioning should be largely equal these days. Use default, that's what it's there for. And in these days where most of your traffic is local, you really can use default a lot and get rid of more specifics. Everyone will thank you, including your router. Juniper have now finally come up with hot caching, hot compression. And I think it kind of works because it's no longer as important. You can get away with the slight lags that are associated with fib compression and hot caching. It's worth looking at as a way of not spending a fortune on massive TCAM memory. So in some ways, those opportunities now exist as the routing system sort of gets more constrained. So that's a quick overview of the internet as it stands. I think we've largely seen, a bit like the Roman Empire, its rise, its peak, and now we're watching it tip over the edge and slowly and gently decline in importance as we move on to the wonderful world of AI. Thank you.
Thank you so much, Jeff. Any questions for Jeff from the floor, please?
Fantastic. That was him going out for water. Thank you very
All right,
much.
thanks, Jeff. Next up, we'll have Yolandi. There we go. Yeah. Yolandi will come up and talk to us about something with AI and its faces. One or many of them.
All right. Good afternoon, everybody. I hope you're still awake. No, I don't think so. All right. So, yes, another AI presentation. I know this is why we are here, right? To talk about AI. But hopefully today I can bring you a different perspective into AI. Let's talk about should it be used, should it not be used, and everything that goes with that, especially in interconnection and peering. Now, when we talk about AI, usually the thing that people think about is ChatGPT, right? But as we all know, there's much more to AI. There's much more platforms that exist. There are different forms of AI that exist that we make use of. But AI has been around in many shapes and forms, as I mentioned. It's not just now, all of a sudden, there's this big boom about AI. It has been around, just not talked about enough, right? So let's look at some of the examples where it has been used before we all started looking at ChatGPT as the AI. Medical imaging, so detecting diseases from scans with high accuracy, so using advanced platforms that can actually identify diseases using scans. In fraud detection, I mean, this has been around for many years, flagging suspicious transaction in real time, and this is quite essential for all of us, right? Using banking applications, financial institutions, and all of that. Traffic management. I think it might not be here in Jakarta, but optimizing traffic flow and public transport, right? So using these platforms to configure the traffic lights, for efficient traffic flow, depending on the time of day, the amount of traffic, and all of that. Voice assistants, I mean, Siri. Siri has been around for quite some time. We have Alexa and the Google Assistant, right? So these technologies have been around for quite some time. Now, what is the purpose and when did it start? So I was quite surprised, right? That how long ago this all started, right? For me, in my mind, it came about like in the 2000s, right? For me, that's quite a long time ago. But it's actually before that, right? And what was the purpose of AI in that time? So it's machines that could learn, reason, solve problems, and improve themselves over time. That is the goal of AI, right? So when did this start? Back in 1950 is when the initial idea of AI came about. So Alan Turing's vision for AI was computing machinery and intelligence, proposing that to evaluate machine intelligence, right, setting the philosophical foundation of AI. So it goes quite some time, years back, when AI has become the first idea of AI came about. Early programs in AI is 1951, where the first artificial neural network developed the first self-learning checkers program, pioneering machine learning. It then birthed the AI in 1956, where it became an academic discipline. From there, this is where we get the first AI chatbot, really, in 1966, and this was Eliza. So as I mentioned, AI has been coming for quite some time. We just never talked about it, so it's been there. And of course, as I mentioned, when we talk about AI, everybody right now is talking about ChatGPT or GPT in general. Now, for me at least, I mean, we talk about AI, using AI. Should we not? Is it really something we want to introduce? And all of that. And my perspective on this is that if you look at something like calculators, when calculators were introduced into classrooms, the critics feared that students would lose basic math skills because it's basically a cheat, right? So they are not manually actually doing the calculations themselves, but using a computer to think for them, right? So at that time, people feared that, oh my God, they won't be able to calculate themselves. But calculators now are being used everywhere. It's actually a requirement if you go to a school to have a calculator to do your mathematics, right? Then from there, we had the idea of Excel. So having a platform or a software that can help you with calculations, especially in accounting. And again, the same thing happened where critics feared, oh, but it's going to take my job as an accountant. Why are we introducing this? It's going to make mistakes. How can we trust the software? So this is the early stages, right? And today, I mean, when I started coming into the job market, one of the requirements to get an entry-level job is to understand how Excel works, right? So it was one of the requirements. And what I'm seeing today, especially if you look at young people applying for jobs, a lot of them actually in their CV would list prompting in AI as a skill. And that sounds funny right now, but it can be useful depending on how it's being used and the limitations thereof should still be discussed, right? So in my view, I think, years from now, companies will actually require you to have prompting as a skill. That's kind of where it looks like the industry is going. Now, How are generative AI tools being used today? Of course, content creation, so writing articles, marketing copy, scripts, and creative stories. So a lot of people are using AI to really bring their ideas to life. Programming, of course, as we know, assisting developers by generating code snippets or debugging. So I typically used to see a lot of developers have one screen using ChatGPT to check their scripting and their code, and on the other side, they're actually testing the code. Education, tutoring, personalized learning, and explaining complex topics. So for me, this is where I use AI quite a lot, is to ask it questions about things, to really test what the output is, like what is the perspective of AI on a topic. And then business, automating customer service, summarizing reports, and data analysis. So we've seen this being implemented in many industries where you now have chatbots that you can interact with 24/7 when you need assistance on some kind of issue that you have, right? Like insurance, or if you go to your medical aid or whatever it may be. Most of them now have chatbots that simplifies things sometimes. Now, the good benefits of using AI. So a lot of people are talking about, yes, we should be using AI, it's amazing, it's magical, and all of that. And that's true. There are some benefits to using this as a tool. Efficiency and productivity, so automating repetitive tasks, right? This frees up some time for you to do more strategic, more advanced tasks, instead of spending your time on repetitive things that can be automated. Enhanced decision-making, so analyzing complex data and uncovering patterns. As humans, of course, when we get tired, you can make mistakes, right? And sometimes you just need something or someone to validate what you are looking at if they can see something else. So it gives you a different perspective on whatever data you are looking at. Reduction in human error. As I mentioned, we get tired, machines don't, right? So it is useful to have it look over the data to ensure that you are not missing anything, or point out possible repetition patterns or mistakes. Innovation, drive advancements in areas from autonomous vehicles to personalized education. It can be useful to share an idea and have AI take it to the next level, perhaps giving you a different perspective or a different take on the idea that you might have. But of course, with everything that is good, there are bad things as well. And we need to keep this in mind when using this magical software that exists. So, job displacement. We have heard in the news that AI is going to take our jobs. Great. I would like to see it try, and I'm pretty sure a lot of you feel the same, to say that I would like to see AI do what I do and have the skills that I have, right? So there is a risk, definitely in some cases, that AI, especially with repetitive tasks, are taking the jobs of people in lower, I would say, or not lower, but more something that can be automated. But this also gives them the opportunity to skill up and move into a more strategic, more creative role. Now, ethical and privacy concerns. So this is quite a big topic where a lot of people want to use AI, but become lazy in regard to security and privacy. So the concern is there that some people will just upload an NDA and say, AI, please explain to me what this NDA is saying. I mean, have you read the terms and conditions of using an AI platform? Do you know what's happening with that data and who it's making it available to? So this is quite a concern. Not a lot of users actually take the time to understand the implications of loading data or making use of AI itself. Lack of creativity and empathy. AI does not care. Like it does not have feelings, right? So it lacks the human aspect of looking at situations, which, yes, it can be great from an analytical point of view, but sometimes the human aspect is just as important as the analytic skills. Over-reliance and misinformation. So I have seen, especially in my personal life, that people blindly believe AI. So they would prompt something in ChatGPT, and whatever ChatGPT tells them, they believe, right? That is the truth because the internet said so. Not really taking the time to think by themselves, okay, but this does not really make sense, right? Not questioning the information that's being given to you. So that can lead to errors and misinformation. And again, this is the danger of usual or the users out there not understanding how to use AI effectively. Now, caution using AIs. As we know, hallucinations do exist, and I have tested this theory quite some time, extensively, which is quite funny because I used to do some research, again, asking some questions on topics and seeing what AI gives back to me. It would tell me, and it would make it sound so legit that this is what is being said, or this is the answer to my question, with a link. And when you click on the link, the page does not exist. Error 404, right? Some people don't even go that far to click on the link to verify that the information that is given is correct. So my suggestion, and I mean, we should all really follow this regardless, is double checking the output. Is this really the way, what it is? You know, what is being given to me, is this fact, or is this something that is made up? And just checking fact on one article or one link is not enough. You need to do more extensive research. Secondly, beware of biases. So AI can reflect and amplify biases present in its training data. So I hope you have noticed that the more you use something like ChatGPT, it starts to understand the way you think of a situation. And what it then does is give you an answer based on what it thinks you want to hear. So it can create a bias, so giving you information that is based on what it thinks you want to know. Hence, we need to double check the output. Protection of privacy. Again, please be cautious what you put into AI. In some cases, it is stipulated that AI actually owns the intellectual property of anything it gives as an output to you. So even though it's your idea that you might have given into AI to say, oh, let's expand on this, the output that you get out of AI, it actually belongs to them in some cases. And understanding the limitations. AI is a tool, not a replacement for expertise. Again, it's still learning, right? It's still learning from us. So do not just take it as expertise input. It's a good guide, but it does not replace the actual fact. Now, let's talk about the role of AI in interconnection and peering. So, optimizing interconnection strategies. AI assists in designing complex systems by optimizing performance, minimizing latency issues, and generating innovative architectural solutions. So it can be useful, again, to detect patterns and traffic analysis. And there's many software that we can use to actually see this, right? Open source is great for this as well. And it makes life easier for us to then design the networks to optimize our traffic flows. Again, traffic management, to see what makes sense to your network, to identify the paths that we need to follow for our optimization of the network flows. So AI dynamically shapes and routes traffic by analyzing real-life or real-time network usage patterns, prioritizing essential applications, and adapting to shifting conditions to enhance quality. So especially when it sees there or understands that there will be peaks, it then dynamically shifts the traffic and ensures that there's traffic management happening so that you do not reach full optimization or full usage of your ports. Automated network operations, so autonomously managed networks, reducing manual effort and boosting speed, reliability, and security. Again, this is not something new. Enhancing security and threat detection. So this is quite important. As we've seen, cybersecurity has become a big topic, especially in recent years, the last 2 years. The growth of, for instance, DDoS attacks have skyrocketed. And it's now important more than ever to have these tools in place to ensure that your network is protected and being proactive to protect your network. So AI monitors traffic and behavior to spot threats and trigger quick responses, which we really need in this day and age. Facilitating peer-to-peer connections, so we know this, again, this is not new technology, where you can set up bilateral sessions automatically, not having to manually necessarily send an email. Yes, it is still necessary to do that, but if it's automated, that makes life just easier. Predictive maintenance and capacity planning. So this is quite a nice feature. Again, nothing new, where we can predict interconnection failures and bottlenecks by analyzing data, enabling proactive maintenance and smarter resource allocation. Right? So again, repetitive tasks being automated. Now, these are just some of the examples of the tools being used in interconnection and peering. Depending on what you needed to do, here we have Dynatrace, Logic Monitor, Orvec, Juniper Mist AI, Cisco DNA Center. Another list is Arista Cloud Vision, again for monitoring, NetBrain, SolarWinds Network Performance Monitor, Palo Alto Networks Cortex, XOR. And there's many more that exist. So these are just some examples to show that, again, it's nothing new, and there is some use to it if it's used correctly. Now, what about generative AI in interconnection and peering? Usually it is used as a virtual assistant, right? So we go to the same way software developers use ChatGPT to generate code. I started to wonder, as a network engineer, am I able to generate a config using AI without having to go through this thick book of manual to find the right configuration? So writing and validating automation scripts. Is it possible for AI to give me a script that actually works? Secondly, creating and updating network documentation. How quickly or how accurately can generative AI put together a network document for troubleshooting, for instance? Incident response and troubleshooting guidance. Is it possible for me, when there's an issue on the network, to have AI detect and spot the issue and tell me what it is and how to fix it? Formulating policies and configurations. I was curious to see what the opinion of AI is on how this should be done. So I tried it, and this is the output that I got. So the prompt I put in, if I have a link flap at an IXP, what troubleshooting steps can I take to identify the cause of the problem? And as you can see, it actually gave you like a step-by-step guidance as to what you can look at, and even a summary of what should be done. And why I'm highlighting this is that it has progressed over the years, right? And why I say this is that back in 2023, I wrote a blog just out of self-interest, which is about investigating the potential of AI chatbots in network engineering. So what I wanted to test is, would AI give me the script or the configuration to connect to an IXP? At that time, it didn't. This was 3 years ago, right? So just as a summary, I tried out Google Bard. It had no response. It didn't know what to tell me. It said, I'm sorry, I can't give you an answer. ChatGPT gave basic guidelines, but nothing really of value. It did not give a configuration. It basically just said, you should configure your router, you know, the basic stuff that we already know. Shaco, I also tried. It gave a step-by-step config. I was quite surprised. And Microsoft Bing only said go read the manual, which I'm not surprised. You should read the manual. And then Perplexity AI was the best of the 5 that I tested. It actually gave detailed configuration along with links to manuals and guiding documentation and proactive insights. So if you are interested to see the outputs, the blog is available. I actually copied and pasted everything in there if you are interested to see what it showed. But coming to what it's doing today, I actually tested the same prompt in 2025, and as you can see here, it kind of gave the configuration, right? And what I really liked is that it gave the keynotes to say, please, change the example ASN to your own ASN, because you do get network engineers that would just copy and paste it into a live environment and breaks the whole network. So it's nice to see that it is actually pointing this out. And it's nice to see where it has been going over the past 2 years. So yes, it could work, as a learning tool for network engineers just wanting to check something quickly. But I don't know if I trust. I mean, I'm not a network engineer. If you had to ask me to configure this, I would not know if it works or not. But it was nice to see that it is actually trying to give you much more detailed approach. Now, should you use ChatGPT to configure a router? As Neil Fenimore said a few years ago, no, you should not. And the reason for this is that, yes, it can give you some guidelines as to how to configure, but it does not understand the dynamics of the network. It does not have the full picture to actually give you the right configuration for what you need. And the challenge is that if you copy and paste whatever it gives you as an output, you could break the network, right? So I don't think we should blindly trust what AI is giving us and telling us to do. It can be used as a tool, as a guideline, as a learning mechanism, but it really needs your skill and your experience to really understand what it's giving out. So do not just blindly follow this, and this is especially for the younger engineers that really swear by AI. Yes, it's a good tool, but don't just copy and paste it into your live environment. So some of the information that I got rethinking network optimization for AI technologies. So Graphiant has highlighted self-optimized networks will allocate resources, manage congestion, and maintaining performance without constant manual intervention. So pointing out that it is a useful tool for repetitive tasks. Sienna, they're also looking into AI operations and how it can act with intent, apply context, and coordinate across entire networks, which is useful to a NOC. So, keeping an open mind, I am not saying do not use it, it's really up to you. What I am trying to say is that embracing new technology is crucial and avoid obsolete. It avoids you staying behind, right? We need to keep up with technology. And some people use it to further advance, great, but if you get left behind, you're really going to miss the train to the next to the next level of engineering or networking. rational skepticism. Stay curious but critical, right? And hence, when you get an output, please question it. Verify with other sources and ensure that what is being given to you is fact and not just hallucinations from AI. Find a balance. Use AI as a partner, not a crutch. Do not over-rely on AI to do the things that you need it to do, right? You still need to be able to do it yourself. Can you imagine if you are an engineer and the only way you configure is using AI? What if AI fails? What if the AI data centers all shut down at once? Would your engineer know what to do? Would they know the basics of troubleshooting, right? We are talking about, we already have an issue where some of the younger engineers are so used to a GUI that they don't know how to use a CLI. So what if the GUI fails? They do not know how to troubleshoot or access your switches or devices, right? The same goes for AI. Continuous learning. As with calculators and Excel, the best results come from integrating new tools thoughtfully and responsibly into our work and learning. So yes, use it as a tool. It can be powerful. It does help with education, learning, and getting ahead of technology. But please use it for what it is, as a tool. So if you ask Yolandi GPT, could you comment on the use of generative AI for network engineers and interconnection and peering? I think there is a space for it. I think it can be useful, especially with good prompting. But should it be used as the primary way of running your network? Absolutely not, right? So with that, I hope that this has given you some insight as to AI and its role in interconnection and peering. And if you are someone that is putting all your documentation in AI, I hope you're going to read the terms and conditions of what you actually have put into the data learning set. And yeah, that is what I have to say about using AI. Thank you.
Thank you very much, Yolandi. I'm not sure if it's just me, but I've been receiving a lot of updates on stories and things of people taking caricatures of themselves and what they do this past week as AI ChatGPT output. Is it like a thing this past week? I've been just seeing a flood of these.
It
things.
has, and I'm happy you brought that up. So I'm sure most of you on, especially on Facebook, have seen people put the prompt in where you tell AI who you are and ask it to generate a picture of you with everything they know about you. Isn't it scary how much the internet knows about you? Right?
I haven't tried it, but it looks pretty accurate from those people I've seen do it. It's wild. I think if nobody else has done it in the room, it might be just us because everyone's doing it. Any questions for Yolandi?
I think they're tired. They just want dinner.
Yeah, they just had lunch though. Okay. Thank you so much. Appreciate it. Right, that brings us to the end of this session and the day. Just a reminder, the dinner is at 5 p.m. The buses leave for the dinner at 5 p.m. outside by the south lobby. Please use the elevators by the conference to the left, not the ones to the main lobby. We still have some batik shirts rather, by the registration counter. So if you haven't got one and don't have anything to wear tonight, please go get that. No badges, no entry. So please remember that, and we'll see you at the dinner. Thank you all very much. We'll see you tomorrow.